Hello everyone, I am Navaneeth, third year engineering physics student, and I am here to present an assembly language program on finding the total number of bits we need to flip to convert one integer to another. So let us start by taking a look at an example. So here we have two decimal numbers 65 and 80, and our aim is to convert 65 to 80 by flipping the binary representation of 65. Here we can see that uh, in the number 65, in the binary representation of the number 65, the bit set positions 4 and 8 are dissimilar. So we need to flip those two bits to obtain the decimal number 80. So here the total number of bits we need to flip is 2. So let us look at the flowchart. So in the flowchart, initially we will input the two numbers into the register A and B, and what we will do is we will perform XOR operation between the two numbers, and then we will start another algorithm where we initialize the registers B and C with 0 and 8 respectively, and we will perform an operation called rotate A with carry, and if and we check whether the carry flag is set. If the carry flag is set, we will increment the contents of register B, else we will decrement the contents of register C directly, and then we will check whether 0 flag is set. If 0 flag is set, which means the contents of register C has become 0 and we have traversed through all the bits of the XOR value, so we will store the counter value into memory and stop. So we can understand the program more in an algorithm. So here we can see the algorithm for the program, and initially we will load the register A with 65 and B with 80, and we will XOR the contents of B with A and store it in A. So what happens is that when we XOR between these two numbers, we can see that the bits at similar positions, that means 0 0 1 1, all these gets converted to 0, and the bit positions where the bits are dissimilar, they get converted to 1. So we just need to count the positions which are dissimilar. So this can be done by counting the number of ones in the output of XOR operation. So for that, we will start an algorithm by initializing the register B with 0, and which act as our counter variable for counting the number of ones in this output, and register C with 8 for traversing through all the bits of the XOR output. So here in step 4, what we do is we will set carry flag to 0 by initializing carry flag to 1 initially and then complementing it, so that it doesn't create any errors. And then what we'll do is we will perform the rotating operation. So here what we will do is we will take the carry flag along with accumulator content, and what we will do is we will right shift all the bits of accumulator, so along with carry flag. So what happens is the most significant bit of accumulator goes to carry flag, and the carry flag goes to the least significant bit, LSB. So in the initial step, as it does, what happens is this 1 goes to the carry flag, and carry flag is 1. Since carry flag is 1, it increments the contents of the register B by 1. So that's why here B is 1, and then the accumulator content is this. Now we will perform the operations again if Z flag is not set, because C is 7 here, C is not 0, so C flag is not set. We will perform the right shifting operation again. So we will perform this again and again till here in this step we can see that this 1 goes to the carry flag and B is incremented. So we captured the second one also, and then we traverse through all the digits and we reach C is equal to 0. So when C is equal to 0, we reach step 8 and we check is Z equal to 0 which implies it is false condition because contents of register C has become 0 and the 0 flag is set. So we will store the value of B into memory now. So the value of B is 2. So that means there are 2 bits we need to change to convert the number 65 to 80. So here we can see the ALP code written for the same operation. So what happens is we initially point the HL pair to the location 200H, and then we will copy the contents of 200H into B, and then we will point the HL pair to 2001, and we will copy the contents of 2001 to accumulator, and then we will perform XOR operation between accumulator and register B and store it in the accumulator. Now we will start an algorithm where we will initialize the contents of register B and register C with 0 and 8 respectively, and now we will set carry flag to 0 by initially setting it to 1 and then complementing it. Now we will perform the rotate accumulator with carry operation. So we will right shift all the bits of in the accumulator content and along with the carry flag, and we will check if the carry flag is 1. If carry flag is 1, we will increment B, else increment B and directly decrement C. Else if carry flag is not set, we will directly decrement C without incrementing B. And now we will check if 0 flag is set, which means whether the contents of C has become 0 or not. If contents of C has become 0, then we will store the contents of B into the, we will initially move the contents of B into accumulator and then store it at 2002 position in memory. Else we will repeat the process till it reaches the end bit. So that's the program I have written. So that's all from my side. Thank you.